Alright, so we're going to be solving some more rational equations here in the second part of 2-4, and we want to keep in mind that when solving a rational equation we need to follow these steps here. We want to find the restrictions for the equation. These are the values of x that will not work. Okay, the reason we want to find those is because if our answer ends up to be a restriction, we need to cross it off the answer list. We want to multiply through by the LCD to get rid of the fraction, so we're going to be finding an LCD again. And then we're going to solve the resulting equation and verify that our answers are valid by checking our restrictions again. Alright, so here we go. We want to be able to, number one, find restrictions. Here we go. And so I'm going to start off by looking at my equation over on the left here. Begin by factoring the denominators. So we're going to start out by factoring the denominators in order to find those restrictions. It'll make it a lot easier. For instance, I know by looking at this equation that 2 is definitely a restriction, so I know that x cannot equal 2. Alright? But when I look at this third fraction, I'd be guessing at what makes that thing equal to 0. So if I factor this, I actually get x minus, what do we got here? X minus 2 times x plus 5. So one of the restrictions for that fraction would be the same as the others. The other restriction would be -5 that I could not use. So I just need to keep those in mind. Now if you look at the three fractions here, all three of them have an x minus 2, so my LCD has to have an x minus 2 in it. But the third fraction also has an x plus 5, so the other two fractions, again, my analogy yesterday was just to consider the fact that if you were going to add all three of these fractions together, what would I need to see in the bottom of all three? I would need to see not only the x minus 2, but I would also need to see an x plus 5. Alright, so here we go. We're going to start out the same way we did yesterday. We're going to take our LCD, x minus 2 times x plus 5. We're going to put that over 1, and we're going to multiply it by the first fraction of 2 over x minus 2. Bring on our equal sign. We'll take our LCD again, x minus 2 times x plus 5 all over 1 times our second fraction of x over x minus 2. And then we've got a plus sign in between here with 6 over. Now I'm going to use the factored form of this just because sometimes it's easier. So x minus 2 times x plus 5. And I'm going to multiply that by the LCD. X minus 2 times x plus 5. Hopefully you didn't write too big there because even I'm almost out of space here. Alright, so here we go. Again, I'm going to start by cross-canceling, so let's grab another color here. I think I'll use some red here. So in the first set of fractions, the x minus 2 in the denominator and the numerator can cancel each other, and I'm left with 2 times x plus 5. So I'm going to distribute backwards. 2 times x is 2x. 2 times 5 is 10. I have an equal sign after that. In my second set of fractions, the x minus 2's cancel out, and I'm left with x times x plus 5. That leaves me x squared plus 5x. In the last set, the entire denominator cancels out with the entire numerator, and all I have left is plus 6. Wasn't that nice? Alright, so I need to bring the 2x over to the right side, so I'm going to subtract it here, and at the same time the 10 is going to have to move over to the right side as well. So I might as well subtract that at the same time. Save myself a step later on. I've got my 0 on the left side. I have x squared plus 3x and then minus 4, and I believe that will factor out. We should get x plus 4 times x minus 1, and my two solutions would be x equals -4 and x equals +1. Go back, check my restrictions. It looks like both solutions are okay because neither one of them matches the restriction. Alright? I gotta get some water here. Alright, So it says check your solutions using your graphing calculator. Okay? So the way we do this is we want to take and we're going to let the left side of my equation, okay? So just real quick here, you've got your equation. We're talking about the left side here and then the right side, okay? All the stuff on the right side. So we're going to graph each side independently. So I'm going to let f of x equal 2 over x minus 2. And I'm going to let g of x equal x over x minus 2 plus 6 over x squared. And yeah, I'm not using the factored form because I'm going to use the calculator anyway. Plus 3x, excuse me, minus 10. Alright, so let's just double check that. Yep, looks like we're doing pretty good there. So what I'm going to do is I've got two solutions from back here. So I've got x equals negative 4 and I've got x equals positive 1. And what I'm going to do is I'm going to use the graphing calculator to see really if these two sides are equal to each other, if f of x is equal to g of x when x equals negative 4 and x equals 1. Alright, so we're going to go ahead and pull up our graphing calculator here. And I'm going to go to my menu here, and in my Y1 menu, you can see I'm already there in Y1. I'm going to graph that first equation. So I'm going to pull up a fraction here, and we're going to do positive 2 over, and we have x minus 2. All right, and then we're going to go down to Y2. So that's f of x up there. Now my y2 is going to be my g of x equation. So in this case, we have x over x minus 2, and then we're going to do plus, and we need another fraction here. The nice thing is that the graphing calculator will take care of all of this as long as we punch it in correctly. So then we have x squared plus 3x and minus 10. Alright, so what we're going to see is if the graphing calculator, if these two equations actually cross each other at x equals negative 4 and positive 1. So let's see what we got here. So we're going to hit graph, and it looks like we may have to zoom out a little bit here. Oh, I see one crossing right here on the calculator. Okay, so I'd be willing to bet that those two are crossing right there. So I'm going to use my second, and I'm going to use my trace key. I'm going to calculate the intersection, number 5. So I'm going to calculate the intersection. Now you'll notice the cursor is on the blue graph. All right, I don't even know which graph that is. That's Y1. Okay, and what it's asking me for is give me a guess at where they cross on the first curve. All right, so I'm going to guess right there. And then it jumps to the red curve, and it says, give me a guess where they cross on the red curve. And then it just says, give me a guess, so you hit enter again, and look at that, x is equal to 1. That was one of my solutions. So now I know that my answer is correct because my two sides of my equation are essentially crossing each other when x is equal to 1. And by the way, there's your y value too, where they cross. Y equals negative 2. All right, so then I'm going to go to zoom. And I'm going to zoom out. We'll go to number 3, hit enter, and we're going to zoom out and see if we can get the other side. So you can see there's the first time they crossed right over here at x equals 1. We're supposed to have another intersection at negative 4, and it looks like we have that over here at negative 4. So we're going to go to second, trace again. We're going to calculate an intersection, number 5. But this time I want to be on the other side of my graph. So you'll notice it's tracing the blue graph, and all it wants is a guess at where they cross. So I'm going to hit enter. It's going to jump to the red graph. I think I can get a little bit closer there. I'll hit enter again. It says give me a guess. I'll hit enter again, and guess what? X equals negative 4, y equals negative 1/3. So I know that these two are okay. All right. So just by graphing each side of any equation, you can see where the two cross, and you can check yourself and your work. All right, here we go. Next one, number 4. All right, so we have a similar situation going on here. We have some denominators that need to be factored before we can do our LCD. So this middle fraction I'm going to factor into, looks like x plus 5 times x plus 3. All right. So my restrictions, the numbers I can't use, are going to be x equals -5 and -3. All right, so I'm just going to keep an eye on those. My LCD, you'll notice that the left fraction has x plus 5, the right fraction has x plus 3, and the middle fraction has both. The middle fraction's got the entire common denominator. It's going to be x plus 5 times x plus 3. All right, so here we go. X plus 5 times x plus 3 all over 1. Now this time I'm going to do something just a little bit different. I am going to try and show you a shortcut so you don't have to write this out all 3 times. So I'm going to take, and inside this next set of parentheses, I'm going to write my entire equation. 2x over x plus 5 minus x squared minus x minus 10. You'll notice I didn't factor the top of that because I don't want to do that until I've already done the subtraction. So x plus 5 and x plus 3, and then I've got equals 3 over x plus 3. All right? So now normally I would have that LCD written out next to each one of those, but if you take a look at your LCD and your very first fraction here, the x plus 5 in the denominator here would cancel with the x plus 5 in the numerator here. What that leaves me is 2x times x plus 3. All right, well 2x times x is 2x squared. 2x times 3 is positive 6x. All right, so now that I'm done with that fraction, I would again, I'm going to take these guys off here. I would have my LCD in red times this middle fraction here. But you can see as I go to multiply my LCD with the middle fraction, all of the numerator cancels with all of the denominator. So the only thing left, now you got to be careful here because you've got a minus sign. This is going to get tricky. I've got this minus sign, and so all of this stuff, x squared minus x minus 10, that should be, the minus should be distributed throughout that. So I have minus x squared plus x and plus 10. All right, so that takes care of my middle section, and now I need to do the same thing on the end. So I'm going to take, and we're going to get rid of this. It doesn't really matter if we get rid of that or not, but my LCD in red with my fraction at the end, the x plus 3 here and the x plus 3 here cancel each other out. And once again, I'll multiply 3 times x plus 5, which is 3x plus 15. And it just saves you a little bit of writing. And so if that works for you, by all means, give it a try. So now we're going to combine some terms here. 2x squared minus x squared is x squared. 6x plus x is going to be 7x. We've got that 10. And then we've got equals 3x plus 15. So I'm going to have to bring the 3x over to the left. So I'll subtract that, minus 3x minus 3x. I got to bring the 15 over, so again, I'm going to do that at the same time to save myself a step later on. So I have x squared plus 4x minus 5 equals 0. Factoring this guy, we get x plus 5 times x minus 1 equal to 0. I think that works out. So our two solutions are x equals -5 and x equals -1. Everything's looking great, right? But check your restrictions. All right? This guy does not work. X equals -5 is a restricted value. Restricted value. So my only solution here is x equals -1. All right? Now again, we could do the same thing that we did before. We could graph both sides of this on the graphing calculator, and we can see exactly what's going on here. So on this time, the left side of my fraction is the bigger part, so I'm going to let g of x equal, or excuse me, f of x equal 2x over x plus 5, and minus, we have x squared minus x minus 10 over, and again I'm going to leave the bottom unfactored, x squared plus 8x plus 15 and I'm going to let g of x equal 3 over x plus 3. Now remember, we're only supposed to have one point of intersection on these. We came up with two solutions, x equals -5, which we said was no good. Nope. And we had x equals -1, which should be okay. So let's take a look and see what's happening here, especially at x equals -5. All right? So we'll go to our y equals window. We're going to clear out this guy here, and we're going to start off with a fraction again here, number 1, and we're going to put in 2x divided by x plus 5, and then we have that subtraction sign in there, and as long as we type this in just the way we see it, the graphing calculator should take care of that minus. So we have x squared minus x minus 10. Here's our numerator. Denominator was x squared, and then plus 8x plus 15. All right, so there's one side. We'll clear out this guy and just start all over here. So we need another fraction, and this side's the easier one, 3 over x plus 3. All right. Now remember, we got a solution of x equals -5, but we already know that that's a restricted value. So let's see what's happening at -5 here. Okay, so there's one side. Okay, so it looks like we do have a value at x equals +1. You can see where the red and the blue graph cross each other here, and again we could calculate that. So I would go to my menu, I would hit second and then the trace key, and it's going to say number 5 is calculate an intersection. So I would go over there, hey, look at that, I'm already sitting right over there. So I'm on the first curve, I'll hit enter. I jump to the second curve, I'll hit enter. I'll give it a guess. That was easy, wasn't it? Look at that, x equals 1, y equals 0.75. If you look at the other side, I was supposed to have a solution at x equals -5, but if you count over -5 spaces, 1, 2, 3, 4, -5 is right here. Those graphs definitely do not cross at -5. One's below the x-axis, the other one's above the x-axis. There is nothing going on where those are going to cross. And that will always come out in your answers, and it will show up in the restrictions as long as you're paying attention. All right? I do believe that is it. That one looks like your homework. Have fun with that one.
Alrighty then.